Okay, welcome everybody to the Atheist Society lecture for the first one for 2025. Just briefly, with the Atheist Society, we don't have any rules or membership, but we do have a mailing list. So if someone wants to be included on the mailing list to get notifications about the future lectures, you can send me and I'll put you on. We've got the website which has just been updated. All of the transcripts we have for last year have been loaded on, and most of the videos of the talks. Tonight, we'd like to welcome back Robert Bender, and tonight he's going to be speaking about Charles Darwin's work on volcanic islands. So welcome, Robert.
Mr. Darwin went around the world with the Beagle, captained by Robert Fitzroy, which took 5 years. And at that voyage, they stopped at many volcanic islands. One of Fitzroy's instructions was to work out the longitude of as many islands as possible so they could be recorded by the British Navy and be of use to future sailors who could say, look, I'm in this longitude, the island must be here somewhere. And so they stopped at many, many islands, and it was just a fantastic opportunity for Mr. Darwin. So when he got back, he published his journal of the Beagle voyage, which was massive, some 600 pages, 5 years of exploration around the world. And he then published a book on coral reefs, which I talked about a couple of years ago. And then he published his book on volcanic islands. And then he thought, I've actually finished with the Beagle. But of course he hadn't. It gave him a work program pretty much for the rest of his life. And the origin of species, obviously, to some extent, came out of his work on the Beagle. So, here we go. Before we get into Mr. Darwin, I want to talk about Darwin, the geology student, the miserable, unhappy geology student. So this is from Desmond and Moore's biography of Mr. Darwin. The Wernerian, which I'll talk about in a minute, Natural History Society, met fortnightly in Professor Jameson's room. Professor Jameson was a geology lecturer at the university where Darwin was studying. To the newcomer, setting was stark indeed, but the thronged meetings gave it instant life. Kirk ministers would discuss Noah's flood. Pyros brought their sea slugs and octopuses. Senior students reported on the marsupials shipped from the new Australian settlements. Here, Grant exhibited live sponges and unravelled their structure. Late in 1826, this is when Darwin was 17, Grant began bringing Darwin to meetings. He was 17. Only MDs, that is masters of people with master's degrees, could join. The students came as guests. Darwin was bored by it all. John Judd's introduction to this thing, goes about 7 or 8 pages, has this little paragraph. Only 5 years before, when listening to poor Professor Jameson's lectures on the effete Wernerianism, which at that time did duty for geological teaching, Darwin had found them incredibly dull, his quote, and he declared that the sole effect they produced on me was a determination never, so long as I lived, read a book on geology or in any way study the science. Famous last words. What a contrast we find in the expressions which he makes use of in referring to geological science in his letters, written home from the Beagle. Quote, I am quite charmed with geology, but like the wise mammal between two bundles of hay, I do not know which to like best, because he also liked collecting marine mammals. He was a tireless collector and ended up almost filling the Beagle with his collections by the time they got back to England. The Wernerian is named after Abraham Werner, and you need to know something about him to see how Darwin's work fits in with that. So the Wernerian school of geology derives from a German who developed a theory of the sequence of rocks forming the Earth's crust, which he believed all precipitated from seawater. So his geology is referred to as Neptunism. Whenever you have a drink of water, realise that you are drinking potential rocks. He decided that all granites must have developed at the same time, and all feldspars, grey wax, gabbro, limestone and flint, etc. So any place on Earth with granite had rocks of the same age as every other granite site. Makes life very, very simple. You don't have to date anything. All you have to say, this is granite, and therefore it's the same age as all the other ones. He accepted the idea developed earlier by Steno, who was a Swedish man, that younger rocks are on top of older rocks, and proposed, with a careful eye to the Bible account of creation and the flood, there were a very few stages in the formation of the Earth's rocks. He also named his stages as basic, which means they had no fossils; secondary, with fossils; tertiary, is alluvial sediments recently deposited by rivers; and trap rocks, which comes from the Swedish term trappas, or stairs, but did not accept that volcanic rocks made any contribution to the formation of Earth's crust. We now know that was utterly wrong. Some of Darwin's terminology, as with trap rocks, which he uses many, many times through his book, is clearly derived from Werner. But as with all other geologists, he quickly showed that Werner's simplistic sequence of Earth formation was wrong. And a great deal of his book is pretty much showing that. He doesn't mention Werner at all, but he simply says hundreds of metres of rocks must have taken a long time, far longer than 6,000 years. So this is a map showing the islands down the centre of the Atlantic, and one bunch, the Galapagos in the Pacific, where there's volcanic islands, and Darwin did some of his exploration, and it gave him his opportunities to learn about volcanic islands. So, some words first before we get into Mr. Darwin of what he could do and what he actually did and what he could not do. In our high-tech century, we can learn things about volcanoes that were not possible in Darwin's time. We have seismographic equipment, deep-sea diving submersibles, photography, filming, etc. We also have intensively studied plate tectonics, so we understand why oceanic volcanic islands are where they are, on plate boundaries. This is a product of the 1960s and 1970s, by which time Mr. Darwin had been dead for a century. We have radioactive decay dating techniques, date long ago events. We know about hotspots, such as contributed to the patterns of the volcanoes in the Galapagos and in Hawaii and many other places. The Beagle visited about 7 volcanic islands and groups. There are no volcanoes in England, so Darwin was unable to even begin learning about them until he had left. And the Beagle voyage was the only one on which he ever left England. He stayed home pretty much for the rest of his life, except by examining rocks in academic collections. He was unable to examine the 4,000-metre tall mountains with islands at their peaks, and had no knowledge of the major plate boundaries down the middle of the Atlantic and around the Pacific and Indian Oceans. So all he could do was examine rocks on rambles around islands and try to work out whether the landforms developed underwater or in the atmosphere. Study the different rock types, basalt, tuff, scoria, pumice, and many others, and their erosional stages, and learn something of the sequences of multiple eruptions that formed these islands. Werner, and all his predecessors, had never been to a volcanic island. It was all just stuff out of their heads. Darwin went to many, and so he actually been on the spot. And the earlier theories were actually based upon the idea you didn't need any real experience of volcanoes. All you needed was reasoning. Very much an age of enlightenment period attitude. So one of the first places they stopped at was Cape Verde, just off Portugal. And this is a painting of the Beagle in the main town of Porto Praya. So the journal, this is the Journal of the Beagle, published in 1834. Sorry, 1838. On the 16th of January, 1832, we anchored at Porto Praya in St. Jago, which is now called São Tiago, because it's a Portuguese colony. And this is just an anglicisation of it. The chief island of the Cape de Verde archipelago. Neighbourhood of Porto Praya, viewed from the sea, wears a desolate aspect. Volcanic fires of a past age and the scorching heat of a tropical sun have in most places rendered the soil unfit for vegetation. Country rises in successive steps of tableland, interspersed with some truncate conical hills, and the horizon is bounded by an irregular chain of more lofty mountains. It had not now rained for an entire year, which is pretty hard to believe in the middle of an ocean. When the island was discovered, the immediate neighbourhood of Porto Praya was clothed with trees, the reckless destruction of which has caused, as at St Helena and at some of the Canary Islands, almost entire sterility. So what he's saying is European colonisation was incredibly destructive, which we all know very thoroughly now. So that's what the shape of Santiago is. The geology of this island is the most interesting part of its natural history. On entering the harbour, a perfectly horizontal white band in the face of the sea cliff may be seen running for some miles along the coast and at the height of about 45 feet above the water. So you've got this huge mountain of volcanic rocks and a line of white stuff. And of course, he was really interested to explore that. Upon examination, the white stratum is found to consist of calcareous matter, otherwise known as limestone, with numerous shells embedded, most or all of which now exist on the neighbouring coast. So he went shell collecting on the beaches and discovered the shells there in the rock 45 feet up were the same species. So that was obviously quite recent. It rests on ancient volcanic rocks and has been covered by a stream of basalt, which must have entered the sea when the white shell bed was lying at the bottom. His assumption is the volcanic rocks raised the calcareous matter with the shells in it out of the sea, and therefore the stuff underneath it is newer than the calcareous layer. Within historical times, no signs of volcanic activity have, I believe, been manifested in any part of St Jago. Even the form of a crater can but rarely be discovered on the summits of the numerous red cindery hills. South of Santiago, in the archipelago, is the island of Fogo, an active volcano last erupted in 1814, so 18 years before the Beagle got there. It's a shame he missed it. He might have seen an active volcano and learnt things that you can't learn from a dead one. This is a little map from his book of St Jago with the volcanic peaks just up from the port of Porto Praya, which is at the right end of the bottom end of the map. The island of St Jago extends in a north-northwest and south-southeast direction, 30 miles in length, about 12 in breadth. The lowest rocks exposed on the coast near Porto Praya are highly crystalline and compact. They appear to be of ancient submarine volcanic origin. So what he's saying is the oldest rocks seem to have erupted underneath the water, and therefore they were interacting with cold water, and that affected the form of the rocks. They are unconformably covered by a thin, irregular calcareous deposit, abounding with shells of a late tertiary period. Tertiary was a term invented by Mr. Werner, so we're still using that terminology, and we still do. And this again is capped by a wide sheet of basaltic lava, which has flowed in successive streams from the interior of the island between the square-topped hills marked A, B, C, etc. And you can see on the map there, there's starting from the top right, it's A all the way to F. Still more recent streams of lava erupted from the scattered cones, such as Red and Signal Post Hills, and I'll talk about those in a little while. These rocks possess an extremely varying character. They consist of black, brown and grey, compact basaltic bases with numerous crystals of augite, hornblende, olivine, mica, and sometimes glassy feldspar. By the time he got there, he learnt his rocks. Geology was unbelievably boring. He didn't want to read about it, but he really knew his rocks. And he could just look at one and say, that's feldspar and that's augite. So he was fascinated by this calcareous layer. The stratum is very conspicuous from its white colour and from the extreme regularity with which it ranges in a horizontal line for some miles along the coast. Its average height above the sea, measured from the upper line of the superincumbent basaltic lava, is about 60 feet. And its thickness, although varying much from the inequalities of the underlying formation, may be estimated at about 20 feet. So again, you can do a simple estimate. How long would it take to accumulate 20 feet of shells? Given that shells fly at a certain rate and the sand rises at a certain rate, you can estimate millions of years. At Quail Island, which is going back, Quail Island is in that little inlet in the bottom right corner. It's just a little island in the Bay of Porto Praya. At Quail Island, the calcareous deposit is replaced at its lower part by a soft brown earthy tuff full of turritelli. Turritelli, you can see, are the shells at the top. And I've got some of those in my collection. They're very current. So this must have been quite recent. This is covered by a bed of pebbles, passing into sandstone and mixed with fragments of echini. Echini are sea urchins. So there's bits and pieces of sea urchins. So again, there's sea urchins in the modern world, and therefore this couldn't be terribly long ago. Claws of crabs and shells, oyster shells still adhering to the rock on which they grew. Numerous white balls appearing like pisolitic concretions. Pisolitic was a new word to me, so I looked it up, and it means it's the size of peas, the little pea-sized concretions. Embedded in this deposit, a close examination convinced me they were nullipori, which means they're corals. So what he's seeing is a white layer of what used to be a sandy shore with corals, which occur only at sea level. So the stuff that's 60 feet up, once upon a time was at sea level. And Darwin struggled to explain what was going on there. This is Signal Post Hill. And what you can see in the CBA at the far left and the right is that there are three layers there. A is the ancient volcanic rocks down the bottom of the pile. And B is the calcareous stratum, which you can see is at the left and at the right, and under the hill in the middle, it just disappears. And that struck Darwin as quite curious. And you've got the upper basaltic lava on top of it that also tends to underneath Signal Hill. So the hill excited Darwin because of the remarkable manner in which the white calcareous stratum, in other parts so horizontal, dips under it into the sea. It has a broad summit with obscure traces of crateriform structure. It is composed of basaltic rocks, some compact, others highly cellular, with inclined beds of loose scoriae, of which some are associated with earthy lime. This was part of him studying the different forms of volcanic rocks that formed all these islands. He discovered volcanic rocks are not all the same. In fact, they're amazingly different. And he was really curious to explore how they became so. It has been the source of eruptions subsequently for the elevation of the surrounding basaltic plain. It has undergone considerable denudation. So the Earth formation is very much about upbuild and erosion, in many, many sequences. And he was learning about this. It has been the seat of volcanic action at a remote period. He calls it a remote period because there was no method of dating in his time. He couldn't say anything confidently, this is how long ago things happened. No one had any idea. It showed the last remnants of three small points of eruption. So our modern understanding of the hotspot and the volcanics of Santiago and the Cape Verde Islands, in that map at the top, Santiago is the top left, and the sort of crescent of other islands and the sea levels around them are shown at the bottom right of that diagram. It's on the, or fairly close to the continent of Africa, far away from the mid-Atlantic rift, where the sea is parting and volcanic material comes up and pushes the sea floor aside. It's actually quite close to Africa. So it's not part of the volcanics which came from the recent eruptions along that rift. This is from the web. Cape Verde is a volcanic archipelago situated above an oceanic rise that puts the base of the islands 2 kilometres above the rest of the seafloor. So you've got a flat seafloor and a big hill, and the islands are a several thousand metre layer higher than that. But the base is much higher than the rest of the Atlantic. Cape Verde has been identified as a hotspot. In case you don't know what hotspots are, there is a theory which is very, very strongly supported that there are holes in the mantle of the Earth and there are plumes of magma that come up quite frequently through the same spot. They just don't move. And as the continents are moving over with tectonic plates, every now and then they punch a hole through a continent. And so as they move, you end up with a line of volcanoes, with the oldest one at one end and the youngest one at the other end. And that's what is happening at Cape Verde, which is why there are lots of volcanoes there. As the plate has moved, the hotspot keeps punching holes through different spots. And the most recent one is Fogo, which is the one that's still an active volcano. So it's been identified as a hotspot, and the majority of geoscientists have argued that the archipelago is underlain by a mantle plume, and that this plume is responsible for the volcanic activity and associated geothermal anomalies, which is why a lot of the volcanic islands all around the Earth are in lines. As the plates move, you end up with a series of volcanoes, and this is one of those situations. The islands are geologically principally composed of igneous rocks, which means they've come out of volcanoes, with basic volcanics and pyroclastics. Pyroclastics means that the volcano spits out huge lumps of rock. It's not glugging like vomiting, it's actually spitting out massive bits of rock, comprising the majority of the total volume. The volcanic and plutonic rocks, the plutonic rocks are ones that emerge out of the mantle fairly slowly, are distinctly basic in character. That term is still in use. The archipelago is an example of a soda alkaline petrographic province with a petrologic succession which is similar to that found on other mid-Atlantic islands. So the whole mid-Atlantic ridge has certain things in common all the way down. It goes for about 7,000 kilometres. Mount Fogo is an active volcano which most recently erupted in 2014. So we all missed that. Fogo's caldera is 8 kilometres in diameter. The rim is at an elevation of 1,600 metres, with an interior cone rising to 2,830 metres from the crater's floor level. Calderas probably resulted from the subsidence following the partial evacuation of the magma chamber. And one of the most important parts of Darwin's theory of coral islands is the coral grows on volcanic mountains that are slowly subsiding back into the sea. And so as they slowly subside, the coral can only live just below the sea surface, and so it has to grow taller and taller and taller. And he imagined that there would be hundreds of metres of coral as these things slowly sank. And the really old ones that had sunk a long way just had maybe 1,500 metres of coral sitting on top so that it could stay at the ocean surface. And modern research has shown that was about right. Of a cylindrical block into a supplying magma chamber, in this case lying at a depth of some 8 kilometres. The archipelago has been dated at approximately 180 million years old. That's really, really ancient stuff. That's the first years of the dinosaurs. So no one could not possibly have known anything like that. So the fact that it's so close to the African continent means it's not recent. The only recent stuff is at the mid-Atlantic ridge, which is that red slash in the map at the bottom. Now we need to divert again into the geological timescale. Up to the late 18th century, most amateur scientists still accepted Usher's dating of the Earth for being only about 6,000 years old. And he was a cleric, he wasn't a geologist. He was getting his evidence from the ages of people in the Bible. In the early 19th century, amateur geologists, including Hutton and William Smith, who produced this map that's at the left of the screen, studying the progression of rocks across countries, decided that the history of the Earth was demonstrated in the succession of deposition of rocks. Early attempts, such as that of Abraham Werner, were soon surpassed by mapping rock patterns, as Smith had done in England. Smith was simply someone who contracted to excavate canals all around England. And because he had to excavate many metres down, he noticed the succession of rocks. And in the north of England, they were different from the middle of England, from the south of England. And he got fascinated by it and ended up going all over England and digging holes and produced this amazing map, the conclusion of which is the oldest rocks in the UK are at the north end and they get progressively younger as you go south. And to accumulate all those rocks, probably hundreds of millions of years. That was the end of Usher. Soon became obvious that Earth was far older than 6,000 years, but nobody had any way of measuring how old. Most likely millions of years, but it was just wild guesswork. No one had any real evidence at all. So the current scale, this is the current scale on the left of the screen, all the way from the Hadean to the recent Cenozoic and the Quaternary, where you and I live, where we're standing right now in the Holocene. Though some people are talking about the Anthropocenes, maybe we've left the Holocene behind. And what you've got is various layers of different things which have different fossils in them. It's how you tell the difference. And they go back to some 500-600 million years. So Darwin was familiar with the latest views on developing a series of periods. He refers in his book the Paleozoic era, which you can see is right down the bottom. But he had no criteria positioning any of his volcanic islands into any of the proposed categories. So he didn't. He was pretty cautious. We now know they are all Cenozoic, that is the yellow patch at the top. They're all since the Cretaceous tertiary boundary, since the end of the dinosaurs, because all volcanoes are quite recent. There's no really ancient ones around. So the result, products of ocean floor spreading over the past 50 million years. Another one they stopped at is Fernando de Noronha, which is just off the west coast or the east coast of Brazil. Just off Natal, which is a little city on the corner of Brazil, at the northeast corner of Brazil, 370 kilometres from the continental coast, a 60-kilometre wide seamount with a line of islands just above sea level. And that grey patch down the bottom of the screen is what the side view of that seamount would look like. And it's 4,000 metres tall. It's just teeny-weeny little islands just poking through the sea level. So the mountain just gets up to sea level. Obviously, if once upon a time probably was taller, but the sea has eroded it away. So that's all that's left. Fernando de Noronha archipelago in Brazil is made of solidified lava, primarily salt and phonolite, which is not the same as basalt, from an extinct volcano. The islands are the result of a volcanic event that occurred between 13 and 1 million years ago. That's the current assessment, nothing to do with Darwin. Islands are the remnants of a large volcano that formed in an oceanic intraplate environment. So most volcanoes are where two plates meet. This one was right in the middle of the plate, so it's atypical. The volcano's base is estimated to be 60 kilometres in diameter, and the emerged parts are 4,000 metres above the ocean floor. So 4,000 metres of ocean floor, and then a couple of hundred metres of mountains for us to see there's an island there. It's almost exactly the same depth as the ocean. The volcano's lava was thin and runny, which means there's many, many, many layers, all from different periods, flowing smoothly across the surface and cooling quite quickly. As the lava cooled, it shrank and cracked, forming vertical joints and eroding into cliffs and sea caves. That's the modern interpretation of Fernando de Noronha. Now we get on to another way of looking at it from a map. And you can see the majority of the island has this lines of dots, which if you look at the legend over to the left, it's all phonolite, which is the third last one down near the bottom of the list there. So most of it's phonolite. Phonolite is a variation of the igneous rock trachyte, and a great deal of Darwin's books about trachyte, that contains nepheline or lucite rather than quartz. Lucite just means it's white. A fine-grained volcanic igneous rock composed of alkali, feldspars, and nepheline. So not all volcanic rocks are the same. And Darwin became really, really good at recognising what rocks he was seeing. So this is from his journal from 1838. As far as I was able to observe, during the few hours we stayed at this place, constitution of the island is volcanic, but probably not of a recent date. And 1 million years ago, it probably didn't seem a recent date to him, and we agree. The most remarkable feature is a conical hill, which is in the photograph, about 1,000 feet high, the upper part of which is exceedingly steep. On one side overhangs its base. The rock is phonolite and is divided into irregular columns. On viewing one of these isolated masses, at first one is inclined to believe that it has been suddenly pushed up in a semi-fluid state, like it just burst up, that's the way it is now, into the air. And it looks like that, but Darwin concluded it wasn't. At St Helena, however, I ascertained that some pinnacles of a nearly similar figure and constitution had been formed by the injection of melted rock into yielding strata. In other words, there used to be other rocks around that mountain and they've all eroded away. This is just what's left. Everything else has just been washed away by the sea. This had formed the moulds, these gigantic obelisks. The whole island is covered with wood. From the dryness of the climate, there is no appearance of luxuriance. Halfway up the mountain, some great masses of the columnar rock, shaded by laurel-like trees and ornamented by others covered with fine pink flowers, but without a single leaf, gave a pleasing effect to the nearer parts of the scenery. And he was 23 at the time. He was a great climber. really enthusiastic and very energetic. So it consists of several islets, 9 miles in length and 3 in breadth. The whole seems to be of volcanic origin, though there is no appearance of any crater or any central eminence. The most remarkable feature is a hill. This is from the Volcanic Islands book, by the way. It's published 8 years after the journal. The most remarkable feature is a hill 1,000 feet high, of which the upper 400 feet consist of a precipitate, singularly shaped pinnacle formed of columnar phonolite, containing numerous crystals of glassy feldspar and a few needles of hornblende. So Darwin was a climber, and as ever, examined the fine structure of the rocks very closely. This is him again. From the highest accessible point of the hill, I could distinguish in different parts of the group several other conical hills, apparently of the same nature. St Helena, which he visited on the way back because they weren't able to stop on the way there. There are similar great conical protuberant masses of phonolite, nearly 1,000 feet in height, which have been formed by the injection of fluid feldspathic lava into yielding strata. If this hill had, as is probable, a similar origin, denudation has been here effected on an enormous scale. And this was what taught Darwin the processes of erosion are incredibly destructive, and vast amounts of material is just eroded away. So massive uplift, massive erosion, massive more uplift, more erosion. And it's all been occurring over a very long time. So he was always aware that what he was seeing was not the landscape as it had formed originally, but after much erosion and multiple eruptions, geology in process, far more difficult to interpret. This is St Helena. You might remember St Helena is where Napoleon was imprisoned the last 5 or 6 years of his life, and this is the grave in which he was buried after he died. He's no longer there. This was a British colony, and the French successfully sued the British to return Napoleon to his mother country. He's now buried in a huge mausoleum in Paris, so this grave is no more. The journal records that the Beagle stopped there on the way back to England on the 8th of July, 1836. This is from the journal. This island, the forbidding aspect of which has been so often described, rises abruptly like a huge black castle from the ocean. Near the town, as if to complete nature's defences, small forts and guns fill up every gap in the rugged rocks. And it used to be a major dispute area in the Napoleonic Wars when the British wanted to take it over and the French wanted to take it over, so it was much in dispute. The town runs up a flat and narrow valley, which you'll see in the next slide. The houses look respectable and are interspersed with a very few green trees. Next day, I obtained lodgings within a stone's throw of Napoleon's tomb. It was a capital, central location, whence I could make excursions in every direction. During the 4 days I stayed here, I wandered over the island from morning to night and examined its geological history. My lodgings were situated at a height of about 2,000 feet. The weather was cold and boisterous, and that did not discourage me. We were out every day. And the map there is from the web, and you can see in the centre where they got that little squiggle going up and down, it's Napoleon's tomb, and the house he lodged in was very close to there. So near the coast, the rough lava is quite bare. That is, it's so young that no trees have managed to grow there at all. In the central and higher parts, feldspathic rocks, by their decomposition, have produced a clayey soil, which, where not covered by vegetation, is stained in broad bands of many bright colours. This season, land moistened by constant showers produces a singularly bright green pasture, which lower and lower down gradually fades away, because up higher, the rocks have deteriorated into soil, so things can grow. Down near the sea, it's still rock, nothing can grow at all. He was surprised by the British-looking vegetation, and he learnt that of 747 plant species recorded as in original island vegetation, 52 were indigenous. The English migrants had replaced all of it with species familiar from home and utterly destroyed the local ecosystem. That's what explorers do. Settlers. Ecosystems are crap. All that matters is we want stuff that is familiar to us. He found very few insects. Among these few, I was surprised to find a small Aphodius. The Aphodius is the dung beetle with the brown carapace, and an Oryctes, which, as you can see, are the rhinoceros beetle because of its long horn, both extremely numerous under dung. And that tells you what he did on his walks. If he found some cow shit, he picked it up and looked underneath it, see what was there. And he found these beetles and collected them, of course, send around to his entomologist mates back in England. As goats and hogs had been suffered to range about, all the young trees had been killed. Goats were introduced in the year 1502. He was there in 1836. This is 330 years later. And the dung beetles thought this was fantastic. We love goats. But of course, the local vegetation didn't love goats because it was pretty much gone. So in Darwin's time, in the 1840s, there were no techniques for aging any part of the Earth. Nobody had any idea how old the planet is or could date any geological formation. So Darwin has nothing to say about that. But he tried to work out the sequence of events. The photo at the top left, by the way, is the main town, Jamestown, and you can see why it's a narrow, long town, because you can't build up those hills, just impossible. So all they can do is go along that valley. He tried to work out the sequence of events. The volcanic rises from the seafloor, known to be very deep, so the volcanic mountain must be thousands of metres tall and may have developed as a single volcanic eruption or as a series that gradually built the mountain higher. He had no idea. No one else did either, and he tried to work it out from what he saw on the ground level. Darwin was influenced by Lyell. He published his Principles of Geology the year that the beagle left, and he took volume 1 with him and picked up volume 2 while he was on his travels. Believe in a gradual build-up. So he had to accept that some of the series of eruptions occurred far down in the ocean, and perhaps the most recent occurred once the island had emerged from the water. And constantly through the book, he's trying to work out, was this rock erupted underwater or was this rock erupted in the air? And he had criteria for answering that question satisfactorily for himself. The crater in the north is breached. That's in the map there, which was done by Buch some 20 years earlier. You can see there's a crater there, and it's a breach on the southwest side. Breached on its southwest side, the valley around it showing a history of erosion. So all those little valleys around the coast are the result of erosion from storms into the sea. So Flagstaff Hill and the Barn, you can see in that map at the top left, there's 2 red patches. There's one really big one, that's Flagstaff Hill, and a little one in the top right corner, it's the Barn. And there's an orange one in between, which is much more recent volcanics. So the square angular outline and the black colour of the Barn, which is what's in the photo, at once show that it belongs to the basaltic series, whilst the smooth conical figure and the varied bright tints of Flagstaff Hill render it equally clear that it is composed of the softened feldspathic rocks, so 2 different eruptions. These 2 lofty hills are connected by a sharp ridge, which is composed of the rubbly lavas of the basal series. So Darwin seems to be saying that orange patch is actually older than the 2 red patches. It's actually the other way around. He got that one wrong. Ridge, and likewise the Barn and Flagstaff Hills, are interlaced by dikes. Dikes are just cracks in the ground that are filled up with other material, many of which preserve a remarkable parallelism in a north-northwest and south-southeast direction. Obviously what's happened is the land was invaded by more recent volcanics, which split the old ones and sent up some material which formed narrow channels through the older rocks. That's the modern understanding of it. Dikes chiefly consist of a rock porphyritic with large crystals of augite. So what's augite? So Darwin no doubt got shown in academic collections before he left England what augite looked like, and when he went to the volcanic island, he could say confidently, this is augite, I know that. And he could make studies of the different volcanic rocks that he found. The map at the top is a cross-section of the island, which is a massive wide seamount with a little pimple on top, which is all that comes above the sea. Augite, also known as augurite, is a common rock forming a pyroxene mineral, and there's the formula, CaNaMgFeAlTiSCal2O, if that means anything to you. And just in case it doesn't, there I've translated it into plain English. So the CaNa is calcium sodium. What do we think is sodium calcium? Salt. Magnesium, iron, aluminium, titanium, and then silicon, aluminium, and a bit of oxygen. And that's what makes up the chemical structure of augite, which Darwin didn't know. The chemical analysis of rocks was pretty primitive in his time. A lot of that's been done since his death. Pyroxenes are common in meteorites, and therefore we know that pyroxenes come from the Moon and Mars and Venus, etc. So all the material forming all the planets, the inner planets, is much the same as the sort of rocks we find on Earth. Pyroxenes are the most significant and abundant groups of rock-forming ferromagnesium silicates. They are found in almost every variety of igneous rock. So a lot of the islands that Darwin visited, he said, here's augite again, because he discovered there's a lot of similarities. They also form under conditions of regional and contact metamorphism. So Darwin began the voyage despising geology as boring, learned his rocks, and was competent to examine the multiple eruptions on the volcanic islands visited by the Beagle. A modern understanding of St Helena. Now that we've got wonderful maps, very, very precise maps of the ocean floor, on the right of that map is Africa, on the left is South America, and you can see there's a ridge running right down the centre of the Atlantic. That's where the ocean is spreading, because it's a line of volcanoes which are erupting now at the bottom of the sea. And as they erupt, a lot of stuff comes up from the centre of the Earth and pushes the Earth on both sides apart. And so the continents are separating. Obvious thing to almost everybody who's looked at these maps is that South America fits beautifully into that corner of Africa. But once upon a time, this was one continent, and they're now moving apart. And they've moved apart because of that ridge. And all the parallel lines, both sides of the ridge, are older rocks, which were at the centre 10 or 50 or 100 million years ago. And so the continents are slowly moving apart. St Helena is that little pimple just off the tip of that arrow, which you can see is nowhere near the central rift in the Atlantic. And so it's an old and therefore dead volcano. All the living ones are on that rift in the middle. This is a very old dead volcano. Therefore, it's reasonably safe to live there. So the mid-Atlantic rift is where current volcanism occurs. Stripes either side of it are ocean floor pushed aside by current eruptions. It comprises two volcanoes. The older, dated to 15 million years ago, and South America and Africa were together 50 million years ago. So this is 2/3 of the way of their separation. So 35 million years had gone by before St Helena erupted at the centre of the oceanic rift at the time. It's now well off that rift. So over that time, its seamount had been pushed aside on the African plate, so it remains the same distance from Africa. So what has actually moved is South America. It's slowly moving west. So slow that you wouldn't notice it in your lifetime, 2 centimetres a year. As South America is slowly pushed westward, the island is slowly becoming further from it. It has moved away from the mid-ocean ridge at about 2 centimetres per year. So after over 15 million years, that's 300 kilometres. So it's now 300 kilometres from where the current volcanoes are. So some more about Flagstaff Hill and the Barn. The green patches are the original volcano's rocks. The brown and orange patches are secondary volcano, which erupted 10 to 7 million years ago, all dated by radioactive decay series. Barn is at the northeast corner. Flagstaff Hill to its west, with subsequently erupted rock in between, blood green. The dating is pretty secure. It would have erupted when St Helena was at the mid-ocean rift, but it is now about 300 kilometres east of it. It is surrounded by other seamounts, all of which are submerged, partly due to sea level rise of 135 metres as the last ice age ended and ice caps melted, partly due to long-term erosion and subsidence of all oceanic volcanic seamounts. What's going on is really quite complex, and Darwin had a huge complexity to try to work out on his little voyage. You know, only a few hours or a few days any one site. It was a mighty task. Terceira in the Azores, which is also in the East Atlantic, is the next place they stopped. This is from Desmond and Moore's biography of him. In September 1836, the ship, this is coming back home on the way to England again, the ship crossed the Tropic of Cancer into the temperate north. Quartermasters picked up more provisions on the island of Terceira in the Azores, which is almost home. It's fairly close to Portugal. And of course, Darwin, as soon as they got to land, just jumped off the ship and went exploring. While the barrels were rolling aboard, Darwin borrowed a horse from the consul and galloped off, past Welsh scenery, country yokels and English blackbirds to look at an active crater. It was back on more familiar northern territory, although no fume holes at home, steam whistling from them. And this is from the journal. In the central part of the island, there is a spot where steam is constantly issuing in jets from the bottom of a small ravine-like hollow. He had never seen anything like that in England. This was a totally new experience, which has no exit, which abuts against a range of trachyte mountains. Steam is emitted from several irregular fissures. It is scentless. He's got a very fine nose, Mr. Darwin, he could tell. It soon blackens iron and is much too high temperature to be endured by the hands. The obvious thing to do with steam is stick your hand in it for half a second, and it was too dangerous. He couldn't. So he had to find some other way. And there was no thermometer that could measure that sort of temperature. So all he could say was just too hot. As there is no escape for the rainwater, which trickles down the sides of the ravine-like hollows, whence the steam issues, it must all percolate downwards through the fissures at the bottom, which told Darwin there must be hot rock not far down. And it turns this water into steam and it comes bursting back out. So this is tertiary rock. Central parts of this island consist of irregularly rounded mountains of no great elevation, composed of trachyte, which closely resembles in general character trachyte of Ascension, which is the next island we'll talk about. This formation is in many parts overlaid in the usual order of superposition by streams of basaltic lava, which near the coast compose nearly the whole surface. The course which these streams have followed from their craters can often be followed by the eye. This is off the web now. Tertiary trachyte is a volcanic rock found on Terceira Island in the Azores, different from other trachytes. It is light-coloured, fine-grained, igneous rock that is made up of alkali feldspar and minor amounts of dark-coloured minerals. Trachyte is formed where lava rich in alkali metals and silica cool quickly. It is common in areas where alkali magma erupts, such as continental rift valleys, ocean islands, and above mantle plumes. And trachyte has a silica content of 60 to 65%, which again is a modern assessment, and an alkali oxide content of over 7%. And Darwin didn't have the techniques to make that sort of analysis in his time. So Monte Brasil is a little island, which is all that's left of a volcanic crater just off the coast. The town of Angra is overlooked by a crateriform hill, Mount Brazil, entirely built of thin strata of fine-grained, harsh, brown-coloured. How could he know that? He must have taken a boat around it and got pretty close to the rocks to have a look at the stratification. The upper beds are seen to overlay the basaltic streams on which the town stands. The hill is almost identical in structure and composition with numerous crateriform hills in the Galapagos archipelago. He wrote this book 8 years after he got home, and he'd done huge amounts of comparisons of the various places he'd been. Now, what's tuff? Tuff is a type of rock made of volcanic ash ejected from a vent during a volcanic eruption. Following ejection and deposition, the ash is lithified into a solid rock. Rock that contains greater than 75% ash is considered tough. So again, you need a chemical analysis to clearly classify these rocks. So on with Ascension, and you can see from the map in the bottom left corner, this is where Ascension is quite far down, much opposite the corner of Brazil. This island too was visited when the Beagle was on its way home on 19th of July, 1836. The main point of the Beagle was to map the coast of South America. So they went back and forth, round and round and round for several years, which is why Darwin spent most of his time on the continent of South America. Those who have beheld a volcanic island situated under an arid climate will at once be able to picture themselves the appearance of Ascension. They will imagine smooth conical hills of a bright red colour, with their summits generally truncated, rising separately out of a level surface of black, rugged lava. The principal mound in the centre of the island seems the father of the lesser cones. So there's one old one and some younger ones. The map in the top left corner is out of his book, and the map in the bottom, which is just about the same, is off the web. The settlement, they went to the settlement, which is slightly bigger now than it was then, but still a lot of old buildings. The settlement is near the beach. It consists of several houses and barracks placed irregularly well built of white freestone. The only inhabitants are Marines and some Negroes liberated from slave ships, who are paid and victualled by the government. There is not a private person on the island. That was purely a military barrack. Many of the Marines appeared well contented with their situation. There was a war going on almost every year, and on their island, nobody got shot. They all died in their beds, which is a pretty good way for military people. They think it better to serve their 1 and 20 years on shore, let it be what it may, and in a ship. In this choice, if I were a Marine, I would heartily agree. Darwin was seasick the whole time, the whole 5 years. He got on the boat and he'd just throw up. And they'd spend a week at sea and he'd be throwing up constantly. So he was very, very happy when they landed. He just never got over his seasickness. So, Green Hill. The next morning I ascended Green Hill, 2,840 feet high, and thence walked across the island to the windward point. A good cart road leads from the coast settlement to the houses, gardens and fields, placed near the summit of the central mountain. Near the coast, nothing grows. Further inland, an occasional green castor oil plant and a few grasshoppers, true friends of the desert, may be met with. Some grass is scattered over the surface of the central elevated region. It doesn't match the photo, does it? Because that's much more recent. Green forest has been planted by the locals to make the island more attractive, with trees from Africa, South America and Europe, none of which are indigenous to the island. So again, just like St Helena, they've destroyed the local vegetation and replaced it with other stuff. So the possibility of studying the local ecosystem has gone forever. So from the Volcanics book, the whole is volcanic. And you can see from the photo, the album photo there's a lovely volcano with striated sides and a really pretty crater at the top. And from the absence of proofs to the contrary, I believe of sub-aerial origin. So he thinks those volcanoes erupted in the air, not underwater. Volcanic bombs, these occur in great numbers, strewed on the ground, and some of them lie at considerable distance from any point of eruption. So this was the first time he'd seen signs of volcanoes throwing out huge lumps of rock, which had settled down on the ground and cooled and were easy to pick up. They vary in size from that of an apple to that of a man's body. They're either spherical or pear-shaped, or with the hinder part corresponding to the tail of a comet, regular, studded with projecting points, and even concave. So he was getting a very different kind of volcanism from the glugging sort of runny stuff that he's seen so far. Their surfaces are rough and fissured from branching cracks. Their internal structure is irregularly scoriaceous. And scoria is very gassy, it's got full of bubbles in it. This one was from his book. It was given to him by Major Mitchell, whose cockatoo is one of the rare species in Australia. It was found in sand between the Darling and Murray rivers, far, in fact, 700 kilometres from the nearest volcanic remains. And Thomas Mitchell saw this on his journey up, and Darwin got it, which is just amazing. His correspondence is just astonishing. There wouldn't be any scientifically interested naturalist on Earth that he didn't correspond with. Really amazing man. And the Galapagos, which is probably the most famous part of the journey. So the Beagle arrived at the Galapagos archipelago on 15 September 1835. This is after spending 3 years going back and forth around the South American coast and mapping it, which was Troy's major job, and left the group on 20 October. But Darwin had 5 weeks to explore. He began at Chatham Island, which you can see is at the far right at the bottom, which is now called San Cristobal, because it's now an Ecuador colony, and they've rid of all the British names and put in Spanish names instead. And he moved on to Charles Island, Floriana, which is now its new name, and on the 24th, and then on 28 September to Albemarle, which is the L-shaped one at the far left, and on 2 October to James Island, which is just to the east of Albemarle, and is now called Santiago. And he stayed there for 2 weeks. Briefly visited Culpeper, Darwin, which is not on this map, before leaving on the 20th. So he had 5 weeks and visited 5 islands and had a few days on each one. But his job was to find out whatever he could find out. No one said, this is your job. It was entirely up to him. Of course, he is best known for his observations on the finches and turtles, Darwin's finches and Darwin's turtles and so on. But he actually spent most of his time examining volcanic landforms because he'd been doing that ever since he left home. Whereas the idea that different islands had different finches was just out of the blue, and he didn't really twig for quite a while that was significant. Similarly with the turtles. The governor of the Galapagos said, "You show me a turtle and I'll tell you which island it came from." And Darwin thought, "Oh yeah, that's interesting," and just passed on. He just didn't twig until after he left. And then, of course, he was fascinated. What I could have learned if I'd been there for 6 months rather than a couple of days. So his book has views about Chatham, Albemarle and James Islands until his final chapter, considering why volcanic islands are distributed the way they are, which is really interesting stuff. Chatham found had a great diversity of rock types, each layer hundreds of feet thick from multiple eruptions. And you don't get hundreds of feet in 5 minutes. It's obviously really, really old stuff. So this is San Cristobal, otherwise known as Chatham. Towards the eastern end of the island, there occur two craters. This is from the Volcanic book, composed of two kinds of tuff. One kind being friable, like slightly consolidated ashes. The other compact, of a different nature from anything which I have met with or described. This latter substance, when it is best characterised, is of a yellowish brown colour, translucent, and with a lustre somewhat resembling resin, which he's never seen before. It's totally different. It is brittle, with an angular, rough, and very irregular fracture. How do you know about fractures? He had his geologist hammer, he knocked off bits of rock, and he could see whether he got a smooth outline of the break or he got a very rough outline. And he was really interested in the rocks differed in that way. However, sometimes, being slightly granular and even obscurely crystalline. When seen as a mass of stratification and its numerous layers of fragments of basalt, rectangular and rounded, at once render its subaqueous origin obvious. Position near the coast of all the craters composed of this kind of tuff or pepperino and their breached condition renders it probable that they were all formed when standing immersed in the sea. So what the hell is pepperino? We're about to find out. Working out where the eruption occurred, underwater or in the air, occupied him on most islands. Every island he visited, he's trying to figure out where were these rocks when they first appeared. What's pepperino? It talks about brown coloured tuff or pepperino. So I looked up the web and it says pepperino is an Italian word describing a brown or grey volcanic tuff containing fragments of basalt and limestone with disseminated crystals of augite, mica, magnetite, lucite, and other similar minerals. The name originally referred to the dark-coloured inclusions suggestive of peppercorns, which is how come pepperino. That's from Wikipedia. So I'm getting my geological education as a result. So the second crater, you can see there's a tall crater in the photo and there's a smaller one closer to the camera. The second crater, only 520 feet in height, must have existed until the eruption of a recent great stream of lava as a separate islet. A fine section worn by the sea shows a grand funnel-shaped mass of basalt surrounded by steep sloping flanks of having in parts an earthy and in others a semi-resinous feature. So he's always learning about the different textures of volcanic rocks. Volcanoes aren't all the same. That's what he was learning. And Werner thought all volcanoes were the same, and Darwin showed they really weren't. Right. So the tuff is traversed by several broad vertical dikes with smooth and parallel sides. So all the time he was learning about multiple eruptions which interrupted the rock from a previous eruption, which I did not doubt was formed of basalt until I actually broke off fragments. These dikes, however, consist of tuff, like that of the surrounding strata, but more compact. So the more recent stuff looked different from the older stuff, but it was still the same, and were formed and filled up with the finer mud or tuff from the crater before its interior was occupied, as it now is, by a solidified pool of basalt. He only had a few days each on 5 of the islands, so it's no wonder almost missed noticing the finches and the turtles, as he spent so much time collecting rocks and walking the volcanic landscapes, trying to work out the sequence of island formation. So, Albemarle, this is the really big L-shaped one. This is the one that fascinated him most. This island consists of 5 great flat-topped craters, and his obvious question is, why are they in a straight line? Is that significant? And he decided it was. Which, together with the one on the adjoining island of Narborough, that's the one off to its left, singularly resemble each other in form and height. The southern one is 4,700 feet high, 2 others are 37 and a third only 50 feet higher, and the remaining ones apparently of nearly the same height. He couldn't visit all of them, it wasn't there long enough. 3 of these are situated on one line, and their craters appear elongated in nearly the same direction, which suggests something's going on. The northern crater, which is not the largest, was found by triangulation, measure externally no less than 3 1/8 miles in diameter. That's a pretty massive crater. It must have been a massive explosion when it last erupted. Over the lips of these great broad cauldrons and from little orifices near their summits, deluges of black lava have flowed down their naked sides. Near the seacoast, the stream is several miles wide. It consists of a black, compact base, thickly studded with large, fractured crystals of glassy albite. So what the hell is albite? The high degree of fluidity of that lava stream was at once evident. We'll come across albite fairly soon. 2 craters of tuff on this island are the only remaining ones which require any notice. One of them lies 1.5 miles inland from Puerto Grande. It is circular, about 1/3 of a mile in diameter and 400 feet in depth, and you can see that on the upper photo. It differs from all the other tuff craters which I examined in having the lower part of its cavity the height of between 100 and 150 feet, formed by a precipitous wall of basalt, giving the crater an appearance of having burst through a solid sheet of rock. The upper part of this crater consists of strata of the altered tuff, with a semi-resinous fracture. Its bottom is occupied in a shallow lake of brine, covering layers of salt, which rest on deep black mud. So again, all he wanted to figure out is, how could this come about? How could it end up with that shape as it is now? Its summit is 1,200 feet above the level of the sea, and the interior hollow is 600 feet deep. Its external sloping surface presented a curious appearance from the smoothness of the wild layers of tuff, which resembled a vast plastered floor. And just out off the coast is this thing called Kicker Rock. The upper drawing is from his book, and the more recent photo, which is obviously deliberately taken from the same angle, is off the web. At the distance of a few miles from these craters stands the Kicker Rock, or islet, remarkable from its singular form. It is unstratified, so it's just all a single eruption, and is composed of compact tuff, in parts having the resin-like fracture. It is probable that this amorphous mass, like that similar mass in the case first described, once filled up the central hollow of a crater, and that its flanks of sloping walls, having since been worn away by the sea, to which it stands exposed. So what he's seeing is the result of a long, long period of erosion. A modern description of the rock and its formation process. The rock is a remnant of a pyroclastic, that is a volcano that threw out big rocks, or palagonite cone. It is the site of a volcano eruption that became explosive when lava and seawater mixed. Tens of thousands of years of wind and waves carved its once conical island into the structure we see today. And you can see now it's no different from Darwin's time, which is what you wouldn't expect either. Darwin pretty much got it right. This is the context of the Galapagos, which Darwin had no idea of because it all occurred 100 years or so after he died. So the Nazca tectonic plate, which is the big one in the centre of the map. So Nazca extends down most of the length of South America and is pushing east against the South American plate that is pushing west. So they're bumping into each other. Galapagos is right at the northwest corner of the Nazca plate, where it meets the Cocos and Pacific plates. The Cocos is the little one to the north, and the Pacific's the huge one off to the west of it. So it's right in the corner, and therefore you've got 3 plates interacting there, not just one. So its eruption history has been affected by the relative movements of all 3 plates. There is also believed to be a hotspot plume right under the island group, which makes it even more complicated, which is also moving, which is even more complicated, and brings together 4 plumes of chemically different magmas. So what sort of complexity is that? Make the island's volcanism very complex, way beyond what Darwin could have worked out in the 1830s, but we've worked it out now. So next stop, Tahiti. Journal, November 15th, 1835. They spent years around South America, heading across the Pacific towards home. As soon as we anchored at Matavai Bay, we were surrounded by canoes. This was our Sunday, but the Monday, Tahiti, the dateline. If the case was reversed, we should not have received a single visit. But the injunction not to launch a canoe on the Sabbath is strictly obeyed. They were all Christians by this time, and they took "thou shalt not run canoes on a Sabbath" very, very seriously. On the 17th, 2 days later, after breakfast, I went on shore and ascended the nearest slope to a height of between 2,000 and 3,000 feet, so he's still a climber. The outer mountains are smooth and conical, but steep, and the old volcanic rocks of which they are formed have been cut through by many profound ravines, diverging from the broken parts of the island to the coast. Having crossed the narrow, low girt of inhabited and fertile land, I followed a smooth, steep ridge between two of the deep ravines. The vegetation was singular, consisting almost exclusively of small dwarf ferns, mingled higher up with coarse grass. It was not very dissimilar to that on some of the Welsh hills, and this, so close above the orchard of tropical plants on the coast, was very surprising. At the highest point, which I reached, trees again appeared. The woods in the upper zone are very pretty tree ferns. So he climbed the main volcano. He just loved climbing mountains. On the 18th, the next day, in the morning, I came on shore early, bringing with me some provisions in a bag and 2 blankets for myself and servant. This was a multi-day climb. They were lashed to each end of a long pole, which was alternately carried by my Tahitian companions on their shoulders. These men are accustomed thus to carry for a whole day as much as 50 pounds at each end of their poles. It's 100 pounds on a pole, on a shoulder, going up a really steep cliff. That's amazing. Darwin didn't do it himself. I told my guides to provide themselves with food and clothing, but they said there's plenty of food in the mountains, and for clothing, their skins were sufficient. This is the tropics, and Darwin didn't come from the tropics. Our line of march was the valley of Auru, on which a river flows into the sea by Point Venus. This is one of the principal streams in the island, and its entire source lies at the base of the loftiest central pinnacles, which rise to a height of about 7,000 feet. Glorious place. The whole island is so mountainous, the only way to penetrate into the interior is to follow up the valleys, which is what he did. There's 2 islands. One's called Tahiti Nui, which is the big one, and the other one is called Tahiti Iti, which is a little one, which we'll come to in the next slide. Our road at first lay through the woods, which bordered each side of the river. The glimpses of the lofty central peaks, seen as through an avenue, with here and there a waving coconut tree on one side, were extremely picturesque. The valley soon began to narrow, and the sides to grow lofty and more precipitous. After having walked between 3 and 4 hours, you try doing that in the tropics, we found the width of the ravine scarcely exceeded that of the bed of the stream, which is hence the bottom photo there you can see was the cliffs were narrowing in. On each hand, the walls were nearly vertical, yet from the soft nature of the volcanic strata, trees and a rank vegetation sprang from every projecting ledge. These precipices must have been some 1,000 feet high, and the whole formed a mountain gorge more magnificent than anything which I had before beheld, until he got to Australia, and then he was even more impressed. Until the midday sun stood vertically over the ravine, the air felt cool and damp, but now it became sultry. So you can see there's 2 islands there, obviously 2 separate volcanoes, which are joined by a little isthmus, but once upon a time would have been separate islands. So Tahiti, this is off the web, it's not Darwin. An island in French Polynesia is made up of 2 ancient volcanoes, Tahiti Nui, which is the big one, and Tahiti Iti, which is the little one, and they were formed by volcanic eruptions. The island is surrounded by a barrier reef system. Tahiti Nui, the larger of the 2 volcanoes, formed between 1.4 million and 870,000 years ago. Again, radioactive decay methods used. Papanil River drains the central caldera to the north. Tahiti Iti, located in the southeast of the island and connected to Tahiti Nui by an isthmus of Taravao. Tahiti is part of a volcanic chain formed by the Pacific plate moving northwestward over a hotspot, which is why you've got 2 islands in a straight line. the plate moves northwest, eventually the magma punches a hole in a second place and you get the second island. So it's a confirmation of the plot theory. The islands emerged from the ocean millions of years ago, following a series of underwater volcanic eruptions. So, to volcanic islands again. I visited only part of the northwestern side of the island, and this part is entirely composed of volcanic rocks. Near the coast, there are several varieties of basalt, some abounding with huge crystals of augite, tarnished olivine, others compact and earthy, some slightly vesicular, which means gas bubbles, and others occasionally amygdaloidal. So what's amygdaloidal? In the photo at the bottom, you can see amygdaloidal basalt, which again, he must have learnt from museum specimens in England before he left. These rocks are generally much decomposed, and to my surprise, I found in several sections that it was impossible to distinguish, even approximately, the line of separation between the decayed lava and the alternating beds of tuff. And one of the things that really fascinated him is the joints between different flows of lava. What he obviously had was a dry, cold rock with hot, wet rock flowing over it. What happened at the boundary? He was just fascinated by that. And he made some very early discoveries of what happens at the boundaries where you get multiple eruptions. In the valley of Tia Auru, rocks are basalts with much olivine, and in some cases almost composed large crystals of augite. I picked up some specimens with much glassy feldspar, approaching in character trachyte. There are also many large blocks of vesicular basalt, and there's one in the bottom right corner of the photo, which you can see has got lots of gas bubbles in it. Some volcanic rocks have gas bubbles, some don't, and he was just fascinated at the differences. So the last stop they made before getting back to the Atlantic was Mauritius. As you can see from the photo at the bottom, glorious place. This is from the journal, May 1st, 1836, on the way home. Monday, I took a quiet walk along the sea coast to the north of the town. Plain in this part is quite uncultivated. It consists of a field of black lava, smoothed over with coarse grass and bushes. Next day, I ascended La Pousse, which, as you can see, the mountain there. He loved climbing mountains still, couldn't get over it. A mountain so-called from a thumb-like projection, which is Pousse, what thumb is, which rises close behind the town to a height of 2,600 feet. The centre of the island consists of a great platform surrounded by old broken basaltic mountains, with their strata dipping seawards. The central platform, formed of comparatively recent streams of lava, is of an oval shape, 13 geographical miles across, in the line of its shorter axis. The exterior bounding mountains come into that class of structure called craters of elevation, which are supposed to have been formed not like ordinary craters, but by a great and sudden upheaval. So, La Pousse, that's what it is. How would you like to climb that? This is from his Volcanic Islands book. At the first glance, one is tempted to believe that the sea lately reached the base of the mountains. Several authors have described masses of upraised coral rock around the greater part of the circumference of the island. Between Comorin Bay and the Great Black River, I observed two hillocks of coral rock formed in their lower part by hard calcareous sandstone, and in their upper or great blocks, slightly aggregated of Astrea and Madrepora, which is again two species of coral. And he later wrote, or earlier, had written a book about coral islands and how they formed. He was an expert on coral by the time he got home. And of fragments of basalt. They had a water-worn appearance, and they rose abruptly from a smooth surface. On the coast northward of Port Louis, I found the lava concealed for a considerable space inland by a conglomerate of corals and shells, like those on the beach. Jagged mountains near Port Louis rose to a height of between 2,000 and 3,000 feet, and they consisted of strata of basalt obscurely separated from each other by firmly aggregated or fragmentary matter, and they are intersected by a few vertical dikes, and the dikes always fascinated him. The basalt in some parts abounds with large crystals of augite and olivine. It is generally compact, and he was really interested in compact versus gaseous rocks. So, Mauritius geology, this is the modern understanding. What you can see in the map is there's a long curve of an oceanic boundary, which is obviously where the land is being pushed apart. And Mauritius, which I've indicated with the red arrow, is nowhere near it. So it's not on the plate boundary. It's either a very old volcano that got pushed aside a long time ago, or it erupted in the middle of the plate. We're about to find out. Darwin saw only the northwest coast, which is young basalt. the older volcanics being further south than he had time to explore. Plate boundaries run in a curve from Arabia around Madagascar. Mauritius is well off the plate boundary now. One of the things he was really interested in is, why are volcanic rocks so different? Why aren't volcanoes all the same? We know they're not. This is off the web. The book includes one of the earliest accounts of the process of magmatic differentiation. While observing a basaltic lava flow in the Galapagos Islands, Darwin observed that crystals sink from their weight, and that this throws light on the separation of high silica versus low silica series of rocks. So it's just a purely biomechanical process going on. This was the first proposal of the fractional crystallization hypothesis of magma differentiation that was further developed and demonstrated in the 20th century. So in that respect, Darwin was a great pioneer. In geology, igneous differentiation or magmatic differentiation is an umbrella term for the various processes by which magmas undergo bulk chemical change during the partial melting process, cooling, emplacement of eruption. The sequence of usually increasingly silicic magmas produced by igneous differentiation is known as a magma series, which has become a very, very important part of modern studies of volcanology. Much of Darwin's text is about examining what happens at the boundaries of lava flows when hot lava flows over cold rock and chemically changes it, particularly when lava flows over limestone. What happens to the top few centimetres of limestone? And how a wall of lava looks different at the top and the bottom, having carefully examined crystallization, fracturing properties, response to heating, gas vesicles, conglomerate. He offered no theory of rock varieties, just much observation of their diversity. And the fact that they were so diverse was unknown in Europe before his time, because no one had done this before. So, this is Albemarle Island, which is now called Santiago in the Galapagos. So, right at the end of the book, he has a little section about why are volcanoes where they are. The sequence of volcanoes on Galapagos, Albemarle Island, now Isabella, struck Darwin as remarkable. If the northern three, as you can see, form a straight line, why would you get 3 volcanoes in a straight line? Modern view is eruption sequence starts at Ecuador, which is the left corner, little sort of horse mouth at the top left, then Wolf, which is the top corner, and then Darwin, and then Alcedo, and then Sierra Negra, and finally Serra Azul around the corner. So it looks like the tectonic plate actually turned a corner before the eruption. So we now know the oldest is the northernmost, and they are progressively younger, moving south along the island, taking a sharp right turn at the south end. And that tells us something about how volcanoes form. Darwin had no idea about the relative ages of the volcanoes, but wanted an explanation of the obvious patterns. This is a quote from him. In fact, of the ocean islands being so generally volcanic is interesting in relation to the nature of the mountain chains on our continents, which are comparatively seldom volcanic. So why is that so? Why are volcanoes in the sea and continental mountains not volcanoes? And we now have a clear understanding of that. So this is his book his map from his Coral Islands book. It has a map showing their distribution. All of them, layers of coral atop volcanic islands in curved lines. But why are they all across the Pacific? And why are they all across the Indian Ocean, from India south turning to the west? It's a fascinating question, which he tried to answer, but he didn't have the technology to do it. So, often close to coasts. Much of his work on evolutionary geology was about observing and explaining patterns. These ones had to await the discovery of radioactivity and huge advances in technology. He couldn't map seafloors, which now we can do very, very precisely. So, ocean floor spreading. This is part of South America. Do volcanic eruptions, this is from his book, we may ask, reach the surface more readily through fissures formed during the first stages of the conversion of the bed of the ocean into attractive land? So he thought these eruptions might possibly start forming continents, and he was utterly wrong there. That's not what happens at all. So it did not occur to Darwin to ask what happens with the ongoing volcanism along ocean fissures And what happens to the ocean floor either side of those fissures? We now know it gets pushed apart, and that pushes the continents apart. He just didn't ask that question. So, in a sense, he got it right. As the fissures create new ocean floor material, which is new Earth, and the new land is just the spreading of ocean floor away from the fissures in both directions. It's just an accident. It's got some sea on top of it, but otherwise it's just Earth's surface. And it does, far away, have the effect of raising the mountain chains, so prominent on several continents. South American Cordillera, which you can see there, what you've got in that little drawing is the Nazca Plate subducting underneath the South American continent, which pushes up the mountains of the Andes. And so the spreading of the ocean floor actually does create mountains, which is what he thought it did, but he didn't have a technical explanation of what was going on. He didn't know about subduction or ocean floors or anything. It was all very superficial in some ways. So it raises mountain chains so prominent on several continents. South American Cordillera, Himalaya, pushed up by India, pushing north into it, European Alps, crinkled by Italy and Africa pushing northwards, the Owen Stanleys in PNG, caused by Australia pushing north. All of those are caused by ocean spreading. And we now understand the connection between continental mountains and ocean floor spreading and volcanoes. He could not have anticipated that the ocean spreading eventually subducts under a continent, which is what pushes up a landmass coming from the opposite direction. As with the Nazca Plate, subducting to the west coast of South America, and that's 100 years on. So, summarising the book. In 1843, Darwin had been back in England 7 years, but still not completed publishing the results of his Beagle voyage. He got distracted for 8 years by barnacles. It's just amazing stuff. For years, his manuscript on volcanoes kicked around. Now, as he picked up the subject again, he was mortified to discover just how much remained to be done. He rummaged through his old Beagle notes and called in the specialist reports on his beastly rocks. The whole process took him back to those seasick days of discovery when he set foot on the Galapagos, St. Helena and St. Jago, and his first sight of the obsidian beds and lava bombs strewn over Ascension. How much more those romantic places had meant to him than his turgid 150-page volcanic islands would mean to the geological community. Turgid is a very, very good word for it. I found it very hard going. I've now read it twice, and the second time was much easier because I could understand what he was on about. The first time was hard work. I hope you will read the volume, he declared to his preceptor, Lyell, for if you don't, I cannot think of anyone else who will. It's very sad, all that work. A year later, look at Volcanic Islands, he moaned to Lyell. It cost me 18 months. And yet few had bought it. It sold in a few dozen copies. So I'm one of the few people on Earth who's actually bought a copy. It left him feeling that geologists did not actually read each other's books. And the only reason to write one was to show proof of earnestness. And he was qualified as a geologist because of his proof of earnestness. So, coming all up, Beagle stayed at each volcanic island or group only a few days. So Darwin was much constrained, having far too much to do. Collecting fossils, shells, plant and animal specimens, socialising with the amateur naturalists and hosts he met at each stop. At all the coral atolls and volcanic islands, he diligently walked long distances with his geologist hammer, climbed mountains, studied rock formation and mountain ranges, examined the layers of rock from multiple eruptions and the intervening erosion periods. And he asked questions that have all proved very productive of new, deeper understanding of the planet-forming processes as we now interpret them. Remember, going back to my second slide, Mr. Werner, who governed the geological community throughout Europe for many years, said volcanoes have nothing to do with the formation of our planet. And Darwin showed they do. That's a huge difference. We now understand volcanics is central to planet-forming processes. He was much disadvantaged by the very primitive equipment and procedures available to him as a young amateur. His main function on the Beagle was to be a gentleman companion, so the status-conscious Fitzroy would have someone of his own social standing to talk to. He was the only sort of semi-aristocrat, Fitzroy, that is, on the Beagle. And for him, talk to mere sailors at dinner or any other time was just something he didn't. He wanted someone of his own social status, so he had someone to talk to. 5 years he didn't want no one to talk to, so he took Darwin. And Darwin's main function was to be a companion. And out of that, we got evolution, which is it's amazing. It was a tremendous opportunity for him. He spent the rest of his long life developing ideas to explain what he had observed and collected on that 6-year voyage. Volcanic Islands was not a success when first published. It is probably very little read nowadays. I could be the only person in the last 10 years who's read it, for all I know. It is in every way far out of date, but for its time was a pioneering work. And retrospectively, now that I don't have to read it anymore, I'm very impressed with what was in it. It's quite a pioneering work. So it's wonderful stuff.
Before we hand it over for questions to Robert, I'd just like to make a few announcements. Firstly, we're very grateful to the Unitarians for the use of this hall, and if possible, we'll pass around a box, and if you have any cash handy, it would be gratefully received. Any other announcements?
Yes, Rosalie's here tonight, but the Sea of Faith meeting takes place at the Carlton Library on the 3rd of Thursday.
Okay, that's next Thursday at the Carlton Library.
Announcement from me. A couple of years ago, or 2 or 3 or 4 years ago, whatever, I gave a talk here about Darwin's time in Australia, and another one about Darwin's theory of coral islands. They got used once, and then I put them away. But I offered it to Vanuel U3A, and they said, "Oh yeah, well that's interesting." So I delivered the one on Darwin in Australia Monday this week, and had an audience of 80 people, which is pretty nice. And the one on Darwin and Coral Islands is on next Monday at 2:15 at the Vanuel Library. So I'm recycling it, and I've had to use it twice instead of just once, which is nice.
One more announcement. The Skeptics. The Skeptics have their meeting on the 3rd Monday, which happens to be next Monday, and it's in the Stolberg Hotel. Don't recall the speaker at the moment, but anyway, you can, if you Google Skeptics Cafe, you can get all the details there. I'll start with one question, Robert.
Yes. There we go.
Yeah, thank you for the talk. It was really fascinating to realise that Darwin spent so much time on geology and not as we imagined.
Well, especially starting out as a student, thinking geology was unbelievably boring,
Yes.
and vowing never to read a book and never do any. And she did nothing but for many years.
You mentioned that all of these volcanoes are islands, which makes sense.
Not all volcanoes.
No,
Darwin concluded that most of the volcanoes of the Earth are oceanic underwater volcanic chains. Obviously, Mount St. Helens on the northwest of USA is not an oceanic island. There are some volcanoes that are not, but the vast majority are. Probably 95% of volcanoes are in oceans. Okay. And they all occur at volcanic plates. Now, the Ring of Fire around the Pacific, it's all volcanic islands.
Yeah, okay, so that was my question.
Yeah. So obviously that needs explaining. Why are the volcanoes where they are? And Darwin made a decent attempt to explain where they are. And because he didn't have the radioactive decay series at his hand, he didn't have maps of the ocean floor, he had no seismology figures. It was a pioneering, but the bumbly beginners, the kindergarten level explanation. And we now know much, much better than he did. So he started some good stuff. Technology had at his hands was just very inadequate. Anyway.
Yeah, well, that's interesting. About 95% of volcanoes are islands. Yeah. So what would be the explanation for the other 5%, like Mount St. Helens, who...
Well, one series that's worth understanding is where we're standing right now. There's a long line of volcanoes up the east coast of Australia. And tectonic plate theory has taught us Australia is actually part of Antarctica. If you look at the bight of South Australia, and there's an almost exactly similar coast on Antarctica. So the two once together. There's a rift, there's a volcanic rift in the bottom of the ocean. It has pushed the two continents apart. Antarctica pretty much stayed where it was, and Australia moved away. So Australia has moved north. And while it's been moving north for 50 million years now, it has moved across a hotspot. There is a plume coming up from the centre of the Earth, which every now and then punches a hole through Australia. And what you'd expect over 50 million years is there's a long line of volcanoes, with the oldest one at one end and the youngest one at the other end. And that's exactly what we've got. There's a 45 million year old volcano in central Queensland. And there's younger and younger ones down towards where we are now. The youngest one is Mount Eccles in Western Victoria, which last erupted 6,000 years ago. Eruptions don't just occur once and then that's the end of it. But often you get multiple eruptions at intervals of several thousand years when some plume of magma comes up from the sea. And so the hotspot theory is confirmed very, very clearly by this long line of volcanoes up the east coast of Australia in a nice age series from 45 million years down to 6,000 years.
Just one following up question about the volcanics in Victoria.
Mm-hmm.
In generally, if the volcanoes are due to a hotspot,
Mm-hmm.
I don't know if that's the case here,
Mm-hmm.
but can you use the hotspot to predict where the next volcano might break through? I mean,
Yes and no. You can't predict precisely where or precisely when. What you probably can predict is it won't be north of Mount Eccles, it'll be south, because Australia is still moving north at about much per year. And since Mount Eccles blew up 6,000 years ago, we've moved hundreds of metres, and therefore most likely the next one will be a bit south of Mount Eccles. And I've seen one map forecasting where it'll be on the northwest coast of Tasmania, which is a possibility. It's just a wild guess. We'll know when it happens. Until then, it's just a wild guess, but almost certainly it will be south of Mount Eccles, not north, not west, not east, but south.
Do you know what subjects Darwin studied at uni?
He initially studied medicine and anatomy.
He did an arts.
Yep.
Nobody didn't.
Well, that's what the gentry did. The point was to study something that you didn't have to earn a living, except his father was a doctor. And he said, I want my son to be a doctor. So he started off studying medicine. And after he fainted a few times, his father said, okay, medicine's probably not a good way to go. If we're training you for the church, you better go and study theology. And he sort of made a little dab at it, but he wasn't terribly excited by it. He was much more interested in his beetle collection, which I'm told is very normal. The beetle collecting parson in a little country village was accepted as part of the culture at the time. Someone who wrote for half an hour a sermon for Sunday and spent the rest of his week collecting beetles.
What was his circumstances of living? Did he have a estate, or did he have an amounts of money in the bank or something?
I don't think his books earned very much. Volcanic Islands probably earned nothing. The Origin of Species sold out the day it was published, and they had a dozen editions before he died, so that probably earned him a fair bit of money. Most of it was inherited from his family. His wife's family were the Singh family, I can't remember the name now.
Bank of England used to give 75%.
They probably had their money in the consols. Yeah, his wife's family was quite wealthy. His father was quite wealthy and had inherited vast amounts from his grandfather. So I think he was like most of the gentry, living on inherited wealth. He didn't have to earn a living and therefore could just indulge himself in endless experimentation. He had dozens of experiments going on any one time at Down House. I've been to Down House and I've been in his study and seen the records of all his experiments. It's absolutely amazing man. And he had 10 children.
Is that book still in print?
No, that's why I got the second-hand one, which was published in the 1890s. 1910, so it's 114 years old. I looked around for a current edition, and the one that's on my first slide looks as though Volcanic Islands has been republished as a separate book, but the three together don't seem to be.
I think we better call it a night now. It's getting a bit on. So, Robert, thank you very much.
Pleasure.
We look forward to your next talk, which sounds like it might be on South America.
Good day, yes.
Okay.
So, Yeah, well,